Mesmerizing.
Hello, everyone. Welcome to the Hallucination Webinar. We're going to give everyone a minute to join here. I want to thank Al Nugent for attending. Been a mentor to us for a number of years, an advisor and board member of Jaxon's. We're very excited to have his influence and excited to dig into this conversation. And Greg Harmon, our CTO, the brains behind the operation here, will be poking at what he's been up to and get a better understanding of what's under the covers of Jaxon. All right. I think we should give another 30 seconds. So, important question of the day. What did Yoda say when he saw himself in 4K?
No, but I've got my face palm ready.
HD, am I?
Yep.
All right.
Not funny, are you?
Fine. What do you call a knight made entirely out of fine china? Ceramic. Okay, I'll be here all day, folks. All right. Let's get into it. We have confirmation we are actually streaming live here. So I think people have shown up to learn about these dang hallucinations and how we can curb them or eliminate them if possible. So we've been doing a lot of work with the U.S. Department of Defense, where we were forced into figuring out how to leverage large language models, generative AI in general, all the latest horsepower of AI, but do so in a deterministic way where we can trust the output. We want to have high confidence that the output from these systems can be relied upon. So we can use them in the DoD's case, mission critical use cases, but for industry and use cases where you actually have high risk and reward by leveraging, risk and or reward, I should say, by leveraging AI. So with that, before we go too deep into the covers here, I'm just curious, Al,
Yes.
With all this hype around generative AI, and you have been in the industry for a while, I think we've talked about, AI being around for decades now. You've seen the AI winter and this new hype cycle here. If you cut through all the fat, what's the common theme across them? What has been our experience with AI that has just been true from the beginning?
Well, I think, unfortunately, the thing that's been true since the beginning is we're still not where we said we were going to be some 50 or so years ago. I go back to Minsky and all of that, but we don't need a history lesson. I think the most important change that's happened in the past, let's say 10 or so years, is we now have a global infrastructure. We now have tools that allow us to do things that are more AI-like. So the fact that there's innovation around large language models and machine intelligence, all of those things, it's also good that AI has been sort of partitioned in a sense. It's not the S, there's the overall term, but there's a lot of focus in individual areas. So there's always been a hype about AI. It's never quite gotten to meet the expectation, but I think we're, no pun intended, we're closer than we've ever been in terms of utility. But at the end of the day, it comes down to trust. Can you trust these tools like any other tool that we may have the opportunity or the requirement to adopt to keep our businesses going, to keep our universities going, or whatever? So that's my opinion, but.
Thank you. Well, you mentioned Minsky. Greg here got to brush shoulders with him at MIT.
Yes.
We were chatting about this earlier. Not much has changed over the years, but you keep saying that we have a new UI. We have a new way of accessing and leveraging these models, and picking up on a word that Al just said, increased utility of those. Greg, any thoughts on?
One of the mistakes that folks make, and this is a a line that I'm fond of rehashing is that AI and more specifically large language models and our new generation of chatbots in particular are wonderful innovation. They're the first new thing in computer science in 50 years.
Yeah.
But what people misunderstand is they're not an innovation in reasoning and all of the things, the computational things that we think AI does. It turns out that they are a wonderful new UI paradigm. It's really good autocomplete. It's so darn good that sometimes it can do a great job at pretending to be some of that internal reasoning as if it were there. And a lot of times it's useful, but it's not guaranteed to be correct any more than good old fashioned autocomplete was. It would usually get a good word. It would save you time. That was useful too. That doesn't make it magically always correct and actually understanding what you're saying and what all the implications of that are and so on and so forth.
Mm-hmm.
Yeah, you used the word reasoning, and I know we've talked about this a lot. I'm going to share my screen here just to give us a visual. So we talk a lot about how the large language models are great at being creative. They're great at fabricating a lot of new ideas or generating a lot of content. And we all know that they're not actually logically creating this content. They're just looking at a pattern and presenting a series of characters that make sense to it. When it comes to reasoning, reasoning systems are where you usually go, but it's a very structured environment. With LLMs being so mainstream, but LLMs being so powerful as they are right now, and leveraging techniques that are, pretty well adopted or being adopted right now around leveraging knowledge bases. People call this the RAG technique.
Mm-hmm.
Greg, I'll point this back at you. Can you talk about I call it the ping pong effect that's going on here, where we have a prompt from a user, it's hitting an LLM, but bouncing off of knowledge base and being run through DSail, our technology that's serving as a fact checker.
Sure. I think we'll have to take this one step at a time. So when you're using a language model, and specifically when you're using one in the form of a chatbot especially, you end up using the inherent knowledge base that's inside the LLM to generate its responses. Like what all of the data the LLM has been trained on is part of its sort of available information from which it can draw its responses. And there are a couple troubles with that, which is that no matter how beefy that training was, there's always something it doesn't know, whether it's because it's proprietary company information, because the LLMs are naturally fixed in time and something new has happened, or maybe it's in there and it's just not getting pulled up to the top because there's a lot of stuff in there and it doesn't always pull up the exact right thing. So the any external knowledge base, and this could be in the form of of a knowledge graph, it could be in the form of a vector database, it could be in the form of a document that you just handed the thing alongside and said, hey, I want you to analyze this document. The cases where you say, hey, please summarize this document for me, and and do it in an inference mode. This is one of the ways that you could do that. That gets injected actually into the prompt. So, in this particular case, rather than being a round trip between knowledge base and LLM, in effect, it's almost like the knowledge base is simply a second input arrow next to the person's. And what the LLM sees is the person's question plus a few preemptively retrieved nuggets from the knowledge base that through one mechanism or another, and there are a lot of different ways you can do this, get injected as part of the prompt as if the person had given those facts. And then the LLM's job is to process both the person and these answers that were just put on top of the pile. There's no guarantee or requirement that it uses those, but it does tend to bring those to the top of the pile, which makes it far more likely that if those are relevant to the person's question, that they will be used. And there's an assumption that anything in the knowledge base must be true, and that you at least trust that. However, it doesn't mean that there's any guarantee that the LLM will actually use that, or on the flip side, there's no guarantee the LLM will ignore it, even if it turns out to be completely irrelevant to the person's question, because your retrieval mechanism isn't necessarily perfect. And since we've got the pretty picture up, I will talk to the DSail, which is our particular guardrail. But folks may have heard of the notion of guardrails in general, and the notion there is rather than looking so much at the input to the LLM, you're looking now at the output. You're saying, does that LLM output past certain heuristic rules that we might put in place. Those rules could be as simple as, a regular expression or an if-then with some string comparisons. Maybe I'm trying to just adhere to a format like JSON as an output. But those rules can also get more complicated. They could be an input to another LLM or a feedback loop to just a whole different prompt chain in the current LLM. That's how a lot of the different agent and prompt chaining techniques will work. Where you're asking the LLM for quality measurements, you're asking it to just analyze and revise its own answer. A lot of different things that can be done there to improve. Again, not the assurance, but certainly the utility of what it outputs. The notion of decel, which is one of our core notions, is that we want to actually combine truly formal, trustable, mathematically provable solvers, things like SAT and SMT solvers on the outputs. And the question becomes, how can you do that with an LLM? An LLM's outputting English, and these SAT solvers are basically solving logical programs in one form or another. And what we've ended up doing there is creating, we'll create a DSL specifically for a particular domain area. For folks who have used our online my.jaxon offering right now, the domain there is software design and software architecture. And so there's a DSL that is pertinent to formally and very precisely describing just the notions that are pertinent to talking about lines and boxes from a software perspective. And what the LLM can do is the LLM can both interpret the user's inputs as well as its own purport solution. I'll refrain from the air quotes, but imagine there's some air quotes when I say the LLM produces a solution, and then using different guardrails, it will produce that not in English, but we want our output to be in this DSAIL language, and our user can then verify that. If we want true assurance, the user needs to verify that the output of the LLM actually captured the ideas that they had in mind, because there is an opportunity for hallucination. But at that point, you can then take what's in that DSL and you can prove it formally and rigorously, with those solvers, and that your output is correct. And in particular, this gets useful not for simple fact checking so much, which is where just comparison back to your knowledge base can come in, but very specifically to when you have a series of complex reasoning and lots of different moving parts. That's where you really need to start looking for the different corner cases and second and third order implications of the kinds of things that aren't going to be spelled out, but can be explored when you have a solver going down all the different potential avenues.
All right, I just switched over to my.jaxon. Just wanted to show Greg's point that he just made there, is that inside of Jaxon, as you're architecting new solutions, we have this button right here, the check mark, that generates the DSAIL and checks against those assertions. And then you get a report. This is a very simple example with one assertion, but you could have dozens or hundreds of assertions that DSAIL would do the fact checking on. All right, before we go too deep into this, I wanted to get back over here to the deck and go back a few slides to the current approaches that people are taking to solve the hallucination problem or address it. Of course, people are trying to improve the training data, the whole adage garbage in, garbage out. But that's really more for those models that are smaller, self-contained, working on use cases that the larger generative AI models aren't really working on. That's not fine-tuning ChatGPT. We're not fine-tuning LLMs. We're fine-tuning more traditional machine learning models. Still, rampant across the industry. It's a good thing. I think that they all have very good utility. We shouldn't just rush to generative AI just because it's there. Number two is, I think, what's in the spotlight, and I'm going to come back to that one in a second here. I just want to ask Greg a question about it, but let me get through 3 and 4 here. 3 is also more for larger tech houses where they're using human in the loop and reinforcing the learning of the models and actually fine-tuning and adjusting the models to specific data. Also, pretty powerful technique, but I haven't seen it for the map. It's really unique in organizations that require that. And number 4 is near and dear to our heart. That's what we've been all about with DSAIL, and we're going to get more into that in a minute. But let me go back to the RAG technique here, which making all the headlines, lots of information flowing about how to leverage this technique. I've talked to companies recently, large companies, Fortune 500 companies, that say, "Oh, we're embracing the RAG technique. We've addressed the hallucination problem." So, Greg, can you pick on that a little bit and explain why you can't just trust a RAG technique and call it done?
Well, I think it boils down to the fact that there's more than one kind of hallucination. Hallucination, and folks will quibble with that word. Is it confabulation? Is it just the model making mistakes as models always have and models always will, just by definition of a model? But it doesn't solve everything. It helps to address factual gaps in factual retrieval. So if you have certain facts that are incorrectly retrieved, but you think you have a resource that has the correct fact in it externally, it's a way that you can address that. If you have gaps in your information, such that one reason that the model might make up a fact is because it simply doesn't have the answer, which can happen because you're asking the question about some proprietary information that wasn't in its training data. Proprietary here isn't just top secret stuff in your company or your organization. Is just anything that didn't happen to be included in the training data and then didn't happen to get captured and distilled from that training data into the model. So it might not have been included, or it simply could be the passage of time. I think we've all gone on to Chat GPT, asked it a question, and then gotten it to tell us, sorry, that's after my cutoff date. I don't know that. And so one way that you can get some of those bits of information into the system without having to retrain the system, which is expensive and time consuming, just at inference time, is just inject a few of the relevant facts, pull them up and inject them. I think it's worth noting that that's how we do it now, so that we can use in context learning in an LLM setting where very, very few organization people are actually have the wherewithal or the really just the justification to be training one of these things versus just using it in inference mode. But the original RAG was originally developed before LLMs arguably existed. It was more of a training procedure where you would keep putting things into the you'd be doing this at training time rather than inference time, just as a way of adding to its knowledge base.
All right. So to sum it up, you can't trust it because you haven't mathematically proven it. And the data you can't have high confidence in, or you can't have 100% confidence in. So symbolic reasoning married in with the RAG technique, the way the Jacksons decided to go about it, does alleviate a lot of those concerns. Mm-hmm. All right, I'm going to skip ahead. I promise we're not going to go too deep technically here. I'm just going to skip ahead to this big graphic, and then I'm going to turn off the screen and we'll just have a conversation for the rest of this. But I just want to tee it up. So we're advocating to create a domain-specific language for your domain of discourse. It would be specific to how your users talk. It would look at key terms and phrases and basically codify them so that we can run it through this test gauntlet. Essentially what we're doing is taking natural language, turning it into this domain-specific language, and then we're able to compile it and run it through this, I call it the gauntlet. One of the pieces of it, Greg alluded to it earlier, is a Boolean satisfier or a solver that is, I liken it back to 6th grade math, where you have a formal proof, and if you recall, you line by line at the end, you had an answer. There was only one answer, and there was no question about it because it was a mathematical proof. That's what these solvers are.
6th grade?
6, yeah, for me.
That was college for me.
Oh, well, I was advanced. All right, as promised, I'm going to turn this off. Actually, one more thing before I turn it off. So for each domain of discourse, you have your own DSAIL that would plug in here. The compiler would need to reflect that, but then the rest of the DSAIL toolchain would be what we've already built. So as we work with customers, as we work on specific use cases, once we've captured a domain-specific language, we're able to use the rest of the machinery. In fact, we're going to be deep in the weeds of this next week, where we're creating one for the Department of Defense where we're working with a subject matter expert and gleaning the knowledge that they have in their head so we can impart it into the AI, I call it the AI, into our system, and then be able to use it for use cases ongoing. Greg talks about it as inference time versus training time.
Training time.
Once we have the DSAIL in place, we can use it for inference time, meaning we can use it for real world applications. Runtime production systems can leverage this technique for those domain specific use cases. All right, teeing that up, Al, I'm going to put you back on the spotlight. Domain specific languages have been around for a while.
They have.
SQL is a domain specific language. People ask me, what's a DSL? And I played around in a kitchen for a little while. I learned the language of the kitchen, and a chef can say, saute onions, and you know exactly what to do. You don't need to be told, go get some onions, dice them, make them a 1/4 inch, put them in a pan, heat it up, don't burn it, all that. It's bloated and left with ambiguity. With DSLs, we have very pointed direction for the machine to machine communication. We haven't, we as a collective proverbial, we've been using DSLs alongside large language models until very recently. But what have you seen DSLs over the years? And sorry to convolute the question here, but I know we've talked about UML as well, having these modeling languages and these reasoning systems alongside computer scientists, developers in general. How have you seen that progression?
Well, it's been interesting. I think we're at a point now where there's so much information and it is so disintegrated and unstructured and all of that one of the only ways to kind of get out of that mess is to be very, very specific within the context of a domain or adjacent domains, even, because, let's face it, cross context is going to be really important here. You mentioned the notion of the kitchen, and you're right. Saute onions means something, but okay, sliced onions, diced onions, red onions, scallions, butter, olive oil. So there's this monopoly of things that happen. One of the areas that we've discussed amongst ourselves, but is absolutely paramount. In the beginning of the computing world, I hate to get rudimentary, and I'm not going to wax melancholic or anything like that, but it was garbage in, garbage out. That's something everybody's learned. And so at the end of the day, tools are great. Data is better. Data is important. Information, content, bucket it any way you wish. As you guys know, I've been spending a ton of time in the healthcare space over the last 10, 15 years. If there is ever a domain with a significant problem around data, it is absolutely the healthcare space. Deeper you get in, the worse it gets. From a certain point of view, the only way out of that mess, the only way to make that data, to give it utility, to make that data approachable, that information approachable, is to be specific about the language of that domain. I've seen a lot of attempts. Regina Barzilay at MIT has done a lot of work with Mass General on natural language processing. Great, but it's not enough. It's just they're sort of working around the edges of the problem, because the problem is, how do I make all of this data relevant in a particular area and consumable by people with varying sets of experiences and knowledge and all of that other fun stuff. So I was recently having a discussion with some partners the other day, and they mentioned DSL, and somebody actually thought that was digital subscriber line. Get back to the ISDN days, and it's like no. We're I hate when we reuse I hate acronyms, but when we reuse them, it's even worse. So at the end of the day, people have been working around, you know, ontologies, if you will, in specific areas for the entire existence of the computer industry, probably before it and certainly outside of it. But today we really have some real opportunity with the tools and technologies that are available to create robust DSLs and marry them to specific use cases or areas of interest.
Thank you. You just triggered another two thoughts. One, I'm going to point back at Greg, and then I'll take back the mic to talk about healthcare again. But you said the word ontologies. This came up in a conversation earlier this week. Someone asked me, what's the difference between an ontology and a DSL?
And a taxonomy.
And a taxonomy.
And a vocabulary.
Well, bear with me. Let's ask ChatGPT.
I already did. I asked the boss. I have a general sense. My take on it after talking to the boss is that we can use ontologies as a starting point to build up a vocabulary, but you can't execute an ontology. It's more like having a dictionary at your side. But exactly. The DSL encapsulates that into a format that you can actually use in the gauntlet that I was describing before.
Yeah. It's the difference between just having I think of it not so much as vocabulary. Yes, it's vocabulary, but more your concept dictionary. You know, what are the relevant concepts? And yes, it's got the nouns and the verbs. And you know, when you get to the DSL, that's actually putting them together into sentences that mean things. And in particular, I mean, there's a million ways that you could express those concepts. It's trying to come up with just the right. I hate to go down this rabbit hole, but the right grammars and structures such that it's easy to express the things that are most aligned with the problems you're going to solve. That's why it's domain specific, because you're not trying to make the better language, be it natural or programming, for all things. You're just trying to make something that happens to solve your little tiny subset of problems very, very well and very, very easily. So it's succinct to express your thoughts and your issues there and get your answers back.
One of the other phrases or talk tracks that I like to use, it's about action, right? And I used to use the word animate, but that immediately conjures up, you know, a whole bunch of different imagery for a lot of people. But it is about, as Greg just said, animating or taking action on that. That's the difference from an ontology point of view to a, you know, usefulness point of view.
All right, healthcare. So I've been talking to a number of healthcare organizations, and my understanding is that they are intrigued by generative AI. I want to say it's just AI. I mean, people are attacking on generative AI in general. Can we use AI in general to make decisions? And the answer is profoundly no way, not now, not yet. But they are using them for use cases that aren't as, you know, critical, aren't as impactful as negative outcomes are concerned. So things like patient communications, like reminders, they can use generative AI for that. Where's their hope, Al? Where's their hope within healthcare to actually start using AI for decision making?
Depends on what part of the world you're in.
Okay, fair.
There's a lot of things that you can't do in, let's say, North America that you can do in other parts of the world. But sort of factor the regulatory side out of this. Research is our best hope, because in the research space, while there's not a lot of money there and all, improving the overall efficiency of life science and medical research teams. But I'll give you a very specific example. I don't know how long now, physicians, clinicians, et cetera, have been struggling with the patients like me scenario, right? Go tell me all you can about patients that have this particular setup. And the more complex the data is, the more inconsistent the data is. It's almost impossible to do that. With domain-specific languages, with, you know, generative AI, I think there will be ways for research communities to be able to say, okay, in this context, let's say it's colon cancer, just to pick something. Give me all patients who have presented with colon cancer in the last 2 years with these specific biomarkers, with longitudinal health records that look like this, and and what were the what were the diagnoses, and if any, what were the treatments. You could actually create that and go against a pretty sizable data set and come up with some ideas about where to go next in that journey. At some point, I firmly believe this, that will get commercialized to be able to help with or augment diagnosis and treatment recommendation. But again, we have to then, and now we're back to the regulatory stuff and all. So in underserved parts of the world, these kinds of opportunities may really take root and help. There's always going to be a human in the loop. There have been a number of attempts, for example, to look at radiology images and eliminate the radiologist. Yeah, that's not going to happen. And nor should it really, especially where we are now, given the nascency of everything. So um, I really believe that uh, research opportunities using broadly AI, but very specifically some of the things we're talking about, will create a foundation for kind of the next generation of diagnosis, treatment, or things that can happen differently at the point of care.
Thank you for that. Well, we're over time, but I want to be
Oh,
selfish and keep talking because I have an actual question. Like, I didn't expect this answer, and it's intriguing to me. So I've been talking to someone about scenario planning,
mhm.
creating, synthetic populations.
Yep.
How does that differ from what you were just describing about how we can use it in research? If we have patients like me that are real versus synthetic, do they munge together for research? Is it a new opportunity? Where are you seeing that?
So again, medical space, healthcare space, been using the notion of synthetic data for some time, um, but it has not yet been um, vetted to the point where you can use it in real live active processes, diagnosis, drug discovery, patient identification for clinical trials. I mean, that is a classic example, right? If you can select through the use of the tooling that we're talking about now a better cohort of patients, better meaning more aligned with the objectives of the clinical study, um, then you will likely have better outcomes. The problem with a lot of clinical trials is people have, variances of unknown significance or other things that uh, at some point during the trial maybe make them not such a good participant in that trial, or they have a much higher failure rate than they anticipated. So I think there's some very practical short-term potential areas where again this technology can make a difference if used and have and you have the right guardrails applied.
Right. It seems
And the
seems to me
right data.
one challenge you're going to have is those synthetic patients don't just appear. You had to use some model to create them. Maybe it was an
Sure.
AI model. Maybe this was some expert human just sitting down and doing it, but they are still, have a mental model of the system. All models are going to have some error rate because they necessarily compress the real world into something smaller. And it may be that that error rate is small. It may mostly be insignificant, but you never know, especially when you're exploring sort of new ground and new research where something you weren't aware of turns out to be a critical thing or be part of a critical inflection point.
Yep.
Sure. I thought you wanting to say models are always wrong, but they're right some of the time.
They're useful some of the time.
Useful some of the time. That's the line.
I think somebody might have said that before I did, but maybe not. Maybe
Hey, we really, we're not knocking models because, sometimes.
I knock them every day.
I was referring to the plastic ones that you use glue.
Yeah. All right, very good. Well, thank you so much, Al, for the conversation. I thoroughly enjoyed it. Thank you all for attending. I believe that we have a solution here that can be applied to a number of verticals and a number of use cases. It's a pretty powerful pairing between logical reasoning, these reasoning systems in general with the domain-specific languages, and the large language models that have their own unique capabilities. So I'd love to talk with anyone. Please reach out or try my.jaxon.ai. Thank you all. Thank you, Greg.
Cheers, guys.
Bye.